Greetings and welcome to Accurate Pattern. My name is Polly Sackett, Executive Assistant and a named successor of Accurate Pattern. We are so glad you're joining us for this tour today, where you will learn more about what we do and hopefully come away with some ideas for yourselves. Have you ever wondered how some things are made? There is a dizzying array of manufacturing processes that include patterns, tooling, and molds. Here are just a few examples of our customers' products where we play a key role in creating. Carbon fiber composite body panels, thermoformed covers, fairings, and windshields, plastic molded saddlebags, foam molded seats, fiberglass fabricated hoods, fenders, and cowlings, foundry cast turbine bodies, pumps, and engines, metal spun jet cowling. Accurate Pattern's professional team utilizes the latest technology, intersecting that with journeyman pattern makers' skills and knowledge, turning concepts into reality for patterns and tooling. Stick with us to learn more. Our tour will begin just before shipping with inspection, and we'll move in reverse order through our work centers, all with the end product in mind. At the end of our tour, we'll meet Bruce Williams, founder and president of Accurate Pattern. Bruce will share his knowledge and wisdom as mentor and leader and discuss the company's transition into the next generation. Please enjoy our tour, and thank you for joining us.
My name is Chris Bird, and I work at Accurate Pattern as the quality manager, but also design engineer and manager of purchasing.
Well, can you tell me a little bit why it's important to hold core values in a business?
Well, values lets everyone know what you stand for, and at Accurate Pattern, we actually took our core values of integrity and serving others and teamwork and having the correct attitude and going above and beyond. And we applied that to something called our quality policy, which is basically what we are guaranteeing all those stakeholders. We're going to meet your expectations. We're going to do what we can to grow employees and train them and set them out for the future. So those type of things. And that quality policy is what glues this whole company together. If we notice an issue with one of our products or from suppliers, or even once it gets to the customer site, we fill out a red tag and we let the person who's going to be working on that product know what to do next. We take that information from that red tag and we create a report that we can actually analyze the data from, and determine the best course of action to determine the best possible solution so that this never happens again. But it starts with management and making sure that we have the resources to actually do so.
Hey, welcome to the CMM room here at Accurate. CMM stands for Coordinate Measuring Machine. We have a 3-axis coordinate measuring machine here with a rotatable head, so we're able to get lots of different angles on our automotive fixtures. Automotive fixtures fits into our gauging category. We design, build, and certify them here. The tolerances on this range anywhere from 50 microns to 70 microns. Our machine, however, has an accuracy of about 4 microns, which is just under 0.2 of a thousandth of an inch. Once inspection of these fixtures is completed, we generate a report. We report all the different datum surfaces or nets for a customer with the tolerance bands and the percentage of tolerance that the point is out. The report communicates to the customer that the fixture that we certified is 100% correct to their specifications. It lets them know the exact deviations of each point of interest they are interested in. So right now I have the machine running an inspection sequence. We like to pre-program our CMM so that way the machine takes all the points. So once the inspection sequence finishes rolling, I go and check each point to ensure that it falls within the tolerance that we specified with our customer. And I also try to find the best fit of the points to the fixture.
Yeah, can you tell us about the process of finishing and the paints that we use for it?
Okay, so all of our product virtually gets painted for the model shop, and most of the time it works best to spray. So that's what this area is for. Is we have a mixing station, a gun cleaning, the paint shaker, the solvent in a 55-gallon drum, and then we recycle all of our waste solvent. So this is set up to get the paint ready. Right over here we have a 4x4 benchtop booth, and then to my right we have a large car size spray booth. This booth has air makeup, so it's got a large furnace that while it's spraying we're getting 100% outside air coming in, and of course that's heating it before it comes in, so we can hold whatever temperature we need. We can also bake out with this booth. We can get it up to about 200 degrees Fahrenheit, and that's very good for quick drying some of the paints. We're fortunate in this building we were able to isolate this whole section into its own bay, so that the more you can isolate the fumes, the better. So we're very happy with the way this runs. As far as paints, we have a variety. We have automotive primer, finish coats, anything that you can get at an auto store we may be spraying for some show models or that kind of thing. But most of our work is done with either automotive primer, and we can just take it at 220 grit, or we'll go to Duratec, which is a very solid system for mostly for composites, but we'll use it now for a lot of things. The one we use mostly is a polyester base, so it's catalyzed. You can spray on, typically we'll spray 10-20 thousandths for the easy sand, and then we'll come over with another 10 mil for the top coat. We can get this easily up to 1200 and beyond, but we don't like to tell customers we can do that. So the way it works generally is we'll pre-shape the job in our finishing area and then come over here and hit it with the high build primer, and I believe that's the product here, 707051. We first learned about the Duratec products from our customers. It's a widely used marine coating for both mold work and the final boats, large yachts and the like. And then the top coat we use is 714002, and we have this reducer 39UCE. So the catalyst is MEKP. It's quite dangerous, but we have goggles and using it carefully. It's an excellent system. We've had it for many years and developed some good ways to spray it and then sanding, and very happy with what we can do here. So being a dangerous materials, we need PPE, and one of the systems we have is an air supplied respirator. So this has an air pump that hooks up with a long hose, and it's very nice for the operator to get fresh air, as well as the goggles or the cartridge type mask, gloves, protective aprons and the like. So we care about people and try to get this right safety for them.
At Accurate, we have a model-focused inspection where we compare the real-life model that we create to a fictionally perfect CAD model in our software. How we do that is we use a hexagon roamer arm scanner. You could see me a little bit earlier performing a scan on this model here. And then we use Polyworks software to compare the real-life model to the fictional CAD. I'm going to look visually on the model for things like dust, fingerprints, are all the features there, and service finish. To check service finish, we use flashlights that really shows where there might be some scratches or some heavy finishing areas for us. It just all ensures that we deliver a very high quality product to our customers. After visual inspections are complete, we ensure that the model has the correct surface finish. We can finally digitize it with our scanner roamer arm. To do that, We have a software combination with Polyworks software. This reads the data that we get with our roamer arm. Pretty much there's like a laser light here that reads how far away the model is from the sensor head. And what it's doing is it's gathering millions of little points with XYZ locations and translating it into a solid model in the software. So I can just go along and instantly my model is being digitized from real world to computer with all of the features and aspects that the real world model has. So another thing that we use the roamer arm for is checking toolpathing errors. We have an example here that looks like there's some mismatch here that goes all the way around the model. It might be a purely XY shift by the looks of it, but once we scanned it and checked it out in the software, we found out that it was purely a Z shift. In that case, we'll red tag it and repair the model or rebuild it if necessary.
I'd like to show you around the finishing area here. This is a large area that we set up just for that. It's got a large open space in the middle with access to the larger bay outside of it. We have different ways to handle the material. We have horses, metal horses, wood horses, benches for smaller jobs. We like to make it convenient as we can to work on these jobs. As far as equipment in this area, first of all, we have some large woodworking equipment, a 36-inch bandsaw, 24-inch sander, its own dust collection. The whole area is served by some dust collection. We've got 3 hanging units that help move the air towards the back corner where our dust is captured in our cartridge. The whole room is the whole building is air conditioned, so it stays very nice to work on the projects we need to here. So what we do here is things that maybe should be done on a bench or by hand, assembly. If we have some heavier duty equipment, we sometimes have to make things in the wood shop and then bring them over here and assemble them. So it's just a very convenient area to do all of those operations and then keep most of the other shop clean. Okay, so finishing really is about taking the job from the machine with all of the radiuses the cutters leave, the kerfs, and other defects that we have to bring up to whatever finish the product asks for. Now, most of what we're doing is going to be taking it up to 220 or higher grit finish. I have a wood job next to me. It's common for us to have wood for strength or other reasons, but most of our stuff is in 15-pound or 30-pound or 40-pound tooling boards. That's a little easier to finish than wood. When we're looking at a job for finish, job number 1 is getting shape. So one of the ways you can examine a job is through a flashlight. If you lay it flat and get it to come over, the shadows of defects will pop out for you. Real good for inspection. Some of the tools that we're going to use for shape might include rasp. Now, just to go through the process a little bit, what we normally do is do some of the shaping I talked about. Then we'll take it into paint and give it some kind of primer, either automotive or most of the time it's going to be a Duratec high fill primer. It'll come back from there, and at that point we'll probably Bondo, especially 15-pound. We don't want to Bondo before primer because it is hard. The Bondo is harder than the foam, and you'll get high spots. So by doing the primer, we've got similar hardnesses and we can blend that out. Once we have the primer on, the Bondo in, we're going to do a sanding to maybe 120, 150 and get it ready for a top coat. Then it'll go in for top coat and we'll gradually sand to a finer finish. When we're doing that, we're going to use a marker coat, and that's either a chalk, like a black chalk. The top coat is white, by the way. And then as we sand, we can tell where we've hit and still need to sand more. We'll progressively go up in higher grits, all the way up to 1200 is about the finest finish we need to do. We both dry sand and wet sand. When you're doing sanding, we have various blocks. We found these rubberized blocks and we've added some hook and loop, and it allows our screens to go right on there. The important thing with blocks is it's going to help you hold shape. So either small blocks, you want to go with the biggest block you can, with the stiffest block that flexes to your work. So in this case, we've taken this rubbery type piece and added a piece of styrene to stiffen it up. We even made a sandpaper block out of a piece of styrene just so you could wrap it around something if you needed to sand something. You want to make your life as easy as you can because this is a hard job and we haven't found any robots that do our sanding yet. So a very nice tool is the cabinet maker scrapers, they're called. And they're hardened steel and they come with a hole in that you can get an edge following the instructions. Once you have a good edge, this is a typical simple rectangle. And these are fairly flexible, so you can bend them down onto the shape. And then as you scrape, they give you a lot of control and you can remove material fairly quickly. And by changing your angle, you can gain a very good shape. So there's different ones. We have a rectangle, one with different curves on it. These all comes in kits. And then this one has different radiuses on each end, and then even a French curve for getting in all kinds of shapes. This was a great find some years ago, and it definitely has made life a little easier. When we're using Bondo, of course, we use flexible putty knives, but then these spreaders that you can get at any auto supply store are excellent. You can cut them to different widths, shape them, and become little templates that you can put Bondo on very easily. Bondo cleans off of them, so highly recommended. All right, when we're looking at shape on patterns, one of the best ways to check things is with flexible scales like this. Being a pattern maker, this is a tool that we always use. These are shrink scales, and they're not used anymore because everybody's got calculators and computers. But they work great for this. You can lay it on a job with your flashlight, examine how your shapes are looking, flex them right to the shape, and get things just right. As I said before, shape is job one here, so critically important. We're accurate pattern, not so-so pattern. So as part of our shaping in the finishing area, some old hand tools really come in. I was fortunate enough to be able to get my wife's grandfather and great-grandfather's toolbox, and this goes practically to the 1800s. These chisels are anything from this flat bent shank chisel, this is one of my favorites, to different narrower flat ones, that's a straight, and then rounded chisels. You can tell the difference between a chisel and a gouge because the grind is always on the other side from the flat. This next drawer are gouges. So you can see that this is basically flat, but the grind is on the same side. So a gouge allows you to make a dish shape, whereas a chisel is more designed to come along on a flat and create a flush condition. So these gouges, these chisels, the toolbox itself has been a real blessing to me and very handy to be able to teach other people with. So we have a Merca Solutions system. It's a really nice sanding system. Basically, it's orbital sanders with its own cart. It's got a vacuum that comes on with the orbital. These are electric, so they're powered from the system. When I start this, you'll hear the vacuum come on. These have speed controls on them. And again, they're an orbital sander. What's really nice is the sanding system they have. So they are a screen sanding medium with hook and loop on the back. So all of the devices have that, and then the vacuum is pulled through holes, so of course with the screen, it pulls dust very well. Now, besides keeping your environment and your health better with the dust, it's many times faster to have the dust removed. It's really like wet sanding because you don't have any of the buildup on the paper. So it's been a remarkable system. They've designed it very well with very long hoses, drawers to hold the supplies. There's round, random orbital, there's rectangular, there's hand tools, and these flex, small blocks. So when they fit and when it's the right sanding, they work very fast. So just to sand on here a little bit, this is a small job for this device, but just go slow and sands very nice. Radius is one of the shapes that may not be perfect off the machine or it gets damaged. So when you want to make a specific size of radius on a 90-degree corner, you can use the formula 0.586 or the constant 0.586 times your radius and make that your chamfer. It makes it easier to get at least the 45 of the radius. I'll demonstrate that quick here. So let's say I'm making a 1-inch radius. I'm going to measure 0.586, just approximately here. I'm going to take my rasp and then start cutting. And once I have that line on there, I can use my straight edges to check to get that 45 all the way across. Once that's done, it's very easy to start rounding in, start using my radius gauges to check the perfect size because I've created a tangent surface. So radius gauges are our friend.
My name is Anthony Ferrante. I am a pattern maker here at Accurate Pattern. My main areas of concern are programming for the CNCs and running the CNCs themselves. So right here we have the DMS 5-axis 5T. The 5T is our largest machine here. We have a 16 foot by 11 foot by 48 inch capacity on this machine. We can fit many jobs on it at once, or we can take very large jobs, remove the table, and have access to this entire area for machining. It's a very impressive process. I love watching the 5-axis machine work because you can get at many different angles you can't get with conventional 3+2 machining. It's something I love working on, and I think a lot of the programmers and machinists here enjoy having these machines to make quality products for our customers. We take these stock blocks right here. Here's a finished stock block that we take right from the wood shop over there. We set it up on the machine X, Y, and Z, and the machines are connected through Ethernet to all the computers our programmers use in order to give us accurate locations of the stock blocks once we actually move to programming. It allows for a very high accuracy process, having everything so interconnected in our shop. It's something that I think is very beneficial to the way we do things here. After we machine the part to tolerance, we check it, make sure we have an in-process inspection report to make sure certain features are within the part and make sure they're not overdone or overlooked. And then we take it off the machine, move it over to our finishing area where we have people scan the part to make sure it's within tolerance and then sand it to a smooth finish depending on the part requirements of the customer.
I was basically just a manager at McDonald's, right? I was there for 4 years and had zero experience in manufacturing. I was like in high school, I was on like a robotics team, the first robotics team, but I'd had zero professional knowledge. I also had no college education or anything. And when I came here, they had me out assembling these inspection fixtures that we use for the automotive industry. And I am a curious individual, and so I tried to ask questions, and I eventually kind of wheedled my way into machining, and I started learning how to use CNC machining, and we have 3 Haas machines out there, and so I was rose up into machining until I like to figure out why things work, and so I went on to how I can program. And then so I just kind of started, when I was machining things, I was kind of interject questions about programming, and I would try to learn the software as much as I could. I spent hours off the clock learning the software because it was fun. And then I tried to also, once I started learning more about toolpathing and programming, I wanted to find out ways to improve that process. Have a part, so we have a part like this. This is the final product. And I basically, well, we were machining this before in a very inefficient way. But when we got the job again, we were tasked with finding a better way of trying to automate the process. And what we came up with is we actually built this vacuum table. And underneath this MDF here, we have like a grid of where air can filter in through. And we hooked it up to this, we have a vacuum, this giant 25 horsepower vacuum that runs down here. And I actually, I drilled a hole in through the table. And so it's wired up underneath the table so that it can suck air down into it. And then we have this, the table spreads out the vacuum and for the air to flow through. And I came up with a solution where we hold all these parts, you know, so this is where we start out with. We hold all the 28 parts at a time, but only with vacuum. So one of the most annoying things as a machinist is trying to figure out how the heck you're gonna hold your parts. Either, especially when you can't be touching the profile, and we didn't want different steps or any mismatch in between one side or the other, and so it was really crucial that we were holding on to the part with as little as possible, and so the vacuum achieves that really nicely, where it just we don't really have to worry about. So all we have left is this little thin edge here, and in the final part, that turns into this radius here, and so you don't actually see where we had our second setup for our first to a second setup.
Hi, my name is Dan Jones. I'm the model shop manager here at Accurate Pattern. And welcome to the stock room. This is really where the digital CAD model comes to life. Though we make a wide variety of jobs, the stock process remains consistent by following the best practices. The first step in the stocking process begins with a meeting to discuss the details of the job being made. We go through each page of the drawing package to ensure everyone working on the job understands the end goal. Next, we must select the materials that we will use from a wide variety of choices. This can range from MDF to different types of wood to various densities of tooling board, all the way up to high temperature, high density epoxy boards. There are many factors that affect the choice, such as process type, cost, or longevity of the tool, just to name a few. After the proper material has been selected, we then use various equipment to cut the material to the required size. We have all the tools that are needed to get the job done. This may include a table saw, joiner, planer, disc sander, bandsaw, radial arm saw, or panel saw. Next, we head to one of our granite tables to begin bonding the pieces together. We mix and spread the glue evenly across the surface. Then we use various sizes of clamps and I-beams to ensure that the joints are as tight as possible. After the bonding is complete, we remove all the clamps and prepare the stock for inspection. The job is then checked to ensure all the dimensions are correct. Then it's ready to begin the next phase of its process, CNC machining.
Hi, my name is Kevin Williams. I'm a senior account manager here at Accurate Pattern. I'm going to walk you through our design process. These days, pretty much everything we get comes through CAD. Our customers will send us a file of their final part assembly, either step, IGES, or Parasolid. We'll translate that into one of our 3 CAD packages, SolidWorks, Onshape, or PowerShape. From there, we use our knowledge of mold making and pattern making to evaluate the project and start the initial design. So some of the considerations when we're designing our tooling are part draw, draft, runout, moldability, location features, ease of use for manufacturing, whether it be molding, forming, or assembly, wall thickness, positive or negative tooling. We will typically conference with our direct customer and often the OEM. Most of these meetings now are virtual with the great screen sharing apps like GoToMeeting. Everyone is saving time and having better communication. Once we have good direction for the final product and tooling needed, our design work can really begin. As needed, we change part geometry with draft and radii, add runout, create flanges, cores, and loose pieces, everything the customer will need to produce quality parts. We create multiple conceptual tooling designs and work with the customer to get final approval on their design. Our design process includes creating stock models with shop drawings for the shop to saw, glue, and assemble. Finally, the designer creates specific CAD files for tool pathing, machining, final assemble, and finishing of the tooling. Our designers are highly skilled craftspeople. Our customers have confidence in the solutions we offer.
My name is Ernie Bull. I am a Senior Accounts Manager here at Accurate Pattern. I see my responsibility is to ensure that we exceed our customers' expectations with whatever we provide for them. The only way to do this is to put in the time that it takes to plan projects with our customers. Brainstorming, concept reviews with our customers can be the key ingredient to making this happen. We can do this many different ways: on-site, video meetings, phone calls, e-drawings, or even napkin sketches. Once the details are worked out, we can confidently move into the design phase. One of the perks of my job is that I have the opportunity to create good friendships with some of my steady customers. I have friends and customers that go back over 30 years. And you may not see those relationships that we build on any spreadsheets or pie charts, but that is what we highly value here at Accurate Pattern. Understanding that the success of our customers will always pay out dividends to all the stakeholders involved in the process and is the key to winning. To that end, every Accurate Pattern customer knows that we always stand behind our products to ensure customers are never left hanging. We also recognize that the integrity of our delivery dates is very important, and we strive to never miss. Doing what we say is something our customers can depend on. Our fun family atmosphere here at work makes it enjoyable to work together as a team, and that tends to overflow to our customers and suppliers. Customers also learn soon enough that we take the golden rule seriously here at Accurate Pattern and treat everyone just as we would like to be treated by them.